So in this video, we're going to talk about the find min and find max methods in binary search tree. So we already written the method to find arbitrary data. Now, in addition to that, it's actually is often useful to be able to find the smallest or the minimum data inside the binary search tree. So that's where the find min method comes in. So look at the tree here. Where do we find the minimum or smallest data in this tree? Well, it's 4, isn't it? And as a matter of fact, it's always found by starting at the root, and then we just traverse down the tree until traverse down the left subtree until we hit the end, hit the leaf node, and then that's where we will find the smallest data in the entire tree. Now that kind of begs the question, then what if there is no left subtree? Then where is the minimum data? You should know that, and we'll get back to that in a little bit. So let's write the find min method, and as usual, we have the public version, and then we have the private recursive version. So I already kind of set it up here, and I guess as a matter of fact, I already wrote the sort of our usual base case, and that is if the tree is there's nothing there, right? If the subtree is empty, then we have to tell the caller, hey, the tree is empty. Okay, so now if the subtree, if the subtree root is not empty, then we know the minimum is going to be on the left subtree. So we're going to have to traverse down, keep going down on the left subtree by returning the self dot find min, and then we go down on the left side. Okay, not the right side, left side. Okay, so but then you look at this, and if it calls itself and all it ever does is there's an empty tree error, then we're really never really finding anything. We're really never returning any data at all, right? So okay, so think about it. If we hit if at some point the find min actually raise the empty tree error, that means the left subtree is entirely empty, then where is the minimum error? Where is the minimum data? Well, the minimum data is at the root itself, right? So we then will have to handle the binary search tree empty tree error. Okay, so if the left subtree is empty, then the minimum is what's at the root. So there. Hopefully that makes sense. Let me make sure that's what I said here. Yeah. So let's actually write a test to make sure this is correct. So the test, and I've already written 2 tests. One is a simple one that if the tree is empty, then the find min should raise an empty tree error. Right, so let's run that. Make sure it runs and it's good. So the other test is basically, I said I have a BST and I have a list of data. Now what I'm doing here is I'm going through all the data in there in this list, and I insert each one of these into the binary search tree. Okay, so the first time I'm going to insert 23, the minimum should be 23. The second time I'm going to insert 8, the minimum should be 8, so on and so forth. Now, I don't have to manually test this because what I'm going to do is I'm going to have an empty list, and then each time that I insert a number into the binary search tree, I would insert the same number into the list, and I'll use the min, Python's built-in min, to find the minimum that is in the list, and then I'm going to use the BST find min to that would give me the minimum value in the BST, and I make sure those two are the same. So let me run this test, and hopefully it's all good. Yes, it's all good. So there, that tested our find min method. Okay, so now that we've written the find min method, obviously there should be a find max method, which will return the maximum data in the BST. Should be fairly straightforward to write, and I hope that you would write it and test it.